Możemy zacząć. So as I said, the lectures will be in English and everything we do here will be mostly in English. If there will be some things you need to tell me in Slovak, no problem. We have here our colleague from France. From France, from which university?
La Rochelle.
Ah, no, which city is it?
La Rochelle.
It's the city.
Definitely La Rochelle.
Okay, great to have you here. Last year also had some Erasmus students, and it's not rare, so rare that we have Erasmus students on this course. So I'm glad that they find this course attractive. This course is about aspect-oriented software development. But maybe we should, like as the title says, but maybe it could be also named advanced modularization. So, what aspect-oriented software development is actually, and what are aspects, and what are the limitations, and so on, is one thing. But we always need to modularize software effectively, so to have it under our control. So that we will make some excursions to maybe some other languages that are not labeled as aspect-oriented, but mostly I will talk here in this course about one of the languages that is considered to be aspect-oriented. No internet, right? Let's see. Maybe I always guessed. So this is the list. List of lectures. So in this lecture, the first one, we'll talk about general things, just to get you into this area, and but the examples will be in aspect J, and then we will have this two lectures devoted practically fully to aspect J, and this one will also be mentioning some more advanced point cuts. Not to use this word now. Some more advanced uses of aspect J with respect to this design method called theme, and then we will relate aspects and use cases, but also some examples will be aspects. So our common parlance will be based on aspect J, and there's certain terminology that I already started using, but maybe I shouldn't before we get into some examples that I can show you the exact construct which represent the most important things in aspect J. So when we will have in this course, we will have very focuses very much on discussion. So you will work on your projects, and if you check these course completion conditions. So if we skip these things that basically warn you against some things and so on, this is mostly as in all courses here and in other universities. But if we skip here for how the assessment is distributed, you can see that for period you can get 70% of the assessment or 70 points because persons are points actually mostly here. Some teachers might use a different ratio, but mostly use these correct these percents to assess your achievements. So you can see that out of that, 50 points are for the project and 20 points are for seminar presentation. This seminar presentation is not unrelated to the project. Quite on the contrary, it is actually kind of a precursor to the project, because there you will present what you intend to do. So the project itself is described like what is it about is described here at this page, but to make it short, you first need to think of what you are going to do. So I think that after this first lecture we can talk a bit more on this, because then we will have this exercise lab part of the teaching, so it's kind of continuous just after the break, after the lecture. And we will talk about possible topics more there, but I think that this first lecture will kind of open the space for you, so you can think of what could you do. It's not essential or not absolutely necessary for you to decide like right now what you're going to do, so you can think of this think through, and we can talk about this more the second time we meet, and even maybe the third time, because yes, because the submission for your project objective is October 18th. This is the deadline. So it's kind of a you have plenty of time, but it's better if you can if you find your topic a bit earlier, so that you can start working on it a bit earlier, because I would like you to present do we have here, no, the plan is oh no, I don't have the exact plan here, like in one other course, but roughly we will start at the fourth exercise with some of your presentations. And I have here Jakub and Victor, my PhD students, who will actually guide the labs, and I might be there at some points, but probably I will leave this to them. So they also had this in the past. They had this completed this course, and Jakub is actually exploring some things. His PhD research topic is related to aspect orientation. So I would expect them also to help me with the lectures a bit, so that we are talking about some advanced topics in aspect orientation that they could deliver here. So I think there will be plenty of interesting content in the course. And it's important that I would say at least half of the interesting content is made by you, because your topics can be very different, touching very different programming languages and modeling approaches or whatever, that you will also tell us about in your presentations. And these presentations will start at the fourth exercise, and then continue, I don't know, for up to 10th or 9th, and then 9th exercise, so that we have time for final consultations regarding your projects. In those presentations, it is not essential that you deliver kind of the exact results of your project, because some of you will start kind of very early and with no particular results, but you will make some analysis and talk about that, about what things did you find, and what are the possibilities and so on, so that we can all fit into this time that we have for this course. So we cannot put everything at once or in 2 weeks and so on. So that's why it's organized like this, and it's better if we have kind of, if we take our time and slowly kind of talk about these things. So this is not the presentations are you will get some points for these presentations, of course, but it is not meant to be like a task that you need to resolve and then deliver some result. It is very exploratory work that is required from you. So, as I said, we don't know, by this we don't know exactly what will we have in this course. It depends on you. Part is known, part is known, part is not known. I don't know, Victor and Jakub, they will come with some things in some other languages, maybe JavaScript you mentioned, and TypeScript in general. So we'll see about that, and I completely don't know what, and not even you don't know yet what you will deliver and contribute with. So let's get back. We can talk about this at the exercise part, more about what is expected from you, and about the assessment and everything. But if there are any questions, immediate questions now, just ask.
Can I ask, what did you mean about writing a project about some of the languages, programming languages, if we have to submit codes in AspectJS? If I read it correctly.
No, you don't have to submit. There is a. We will talk about if you studied the website probably. So if you found that there is a required part in AspectJ, yes, there is a small part required in AspectJ, but the big part of your project can be delivered in any language.
Okay.
So you don't have to use AspectJ in your project at all. And moreover, you don't have to have programming involved in your project at all. I think we should start with the lecture, which will start with programming, but we will very quickly get into something that is not programming, and still is very important for software development, and it is important for aspect orientation. So that's why the title is like this, aspects around us, because they're everywhere. First thing is, because like we are programmers, so we best understand things when we see code and very concrete examples, specific constructs, and what do they bring to us as programmers, and how they make things easier for us to do. So that's why I would like to ask you, have you ever needed to change the behavior of a program but without actually modifying it? Think for a moment. Maybe it sounds, maybe if it's not clear, if the question is not clear, it's confusing, just tell me. So you have a program, and you may not change it, or actually you wouldn't like to change it, but you will would like this program to be modified in its behavior. So to affect your program, like without directly spoiling its code, you can write something aside, which actually you may say, then that thing becomes a part of that program. So you're effectively you are changing it. But what I mean is not changing this original version of the program. Have you ever needed this? And in what the situation was? No, no occasion, never. You never said, oh, it would be very nice if I could do this and preserve this program like that. No?
Maybe if I wanted to change to some quicker library or some different SDK, which will do essentially almost the same thing, but
so you needed to introduce some changes, but
to make program quicker,
some optimization.
yes, more effective.
But does it change the behavior?
In some ways, maybe if the library needs some different variables or something, or doesn't support the same things as the previous one. So you have to think about how you can make it work anyways.
Maybe some method should be changed for a different one, but the rest would be the same. Or you should like execute something before that method or afterwards in order to comply to that different library. Any other occasion that you might think? Yes?
Probably in the unit testing. So when we are like trying to test out some functions in unit tests, then we really don't want to modify the functions. We just want to mock functions which actually call the APIs, or like request data or something like that. So that may be the use case for that.
That's interesting. Any other example?
Some monitoring functionality where you can monitor which user used some function and it inputs things answers. Where you don't, when you can't change the signature of the function, but you need to monitor which user run that function.
Why do you want this not to be a part of the program?
Maybe because I need to monitor a lot of functions and I can't change every function so that I have that functionality to monitor.
Actually you can, but it's
yeah, I can, but
it's
not necessary.
Yeah, it will make a mess to your program, and if you would like then to turn off this or switch off or get rid of this, then you will have to change all those functions affected by monitoring. Exactly. This is exactly the case for aspect-oriented programming. So let me see. Make this bigger. This. I don't know why they installed this projector here, so it's like you have this rather small when it could be bigger, but I hope you can read this code. Yeah. So let's see. Start with this one. If you had object-oriented programming with me, and I forgot to mention my name because I had the lectures into other courses, and so I was introducing myself already 2 times. But I guess you know me. I forgot your name. Sorry.
Nathanael.
Nathanael, okay, so I'll try to learn your names during this course. My name is Valentino, and you know me maybe from some other courses, presumably from, or at least from object-oriented programming. If you had different path to these studies, as Nathanael came as an Erasmus student, so maybe we haven't met yet, or? We met. Okay, good. So if you recall some things from object-oriented programming, and in particular the lecture on aspect-oriented programming that I included in this course as well, but it's kind of like an additional thing, and many students do not really follow this, and it's not compulsory to include this in the project and so on, so it's a kind of an optional thing there. So I will be showing some examples that you might recognize from that course, but then we will gradually through the next lecture and the lecture after that go to more advanced things that I cannot show there, or don't have enough time to explain to students. So we will start with the same easy examples as there, and this is like a really small and dummy class that actually does nothing but just has these set and get methods to set two attributes, and it represents a point in a two-dimensional space. And so if you would have this example of the use of this point class, where you create 2 points, actually you create 1 point and set its coordinates. This is a kind of represents small program that you can run and see what are the coordinates. You might want to monitor these things, whether these values are set correctly and so on. So it's a trivial small example, but this might be kind of in other setting. This might be also applicable in kind of really complex programs. So if you would like to follow what's happening, you would need to check whether the attribute is not really set to the value that you wanted to set. You would have to add some lines, either to put this value like to the console, or to put it on a file or somewhere on a log file to follow what's happening. So something like print line can be used as a very primitive solution for this, and so on. So we'll need to add some lines. If you would have some monitoring library or framework that kind of has more advanced things for you, how to follow the values in the program, you can use that. But still, you would need to add some lines to a program like this. it doesn't look so bad because it's a small program. But if you imagine following several values in a big program and so on, it would be kind of all over. And even if you have, if you have this cannot be turned off effectively like from one place. But if you would have this monitoring library, you could turn off monitoring. So these messages will be not present in the output of the program anymore. That's fine. But still, in the program source code, you will see the lines like this that will kind of distract you. Because this class is not about monitoring, it's about a point in space and so on, and you don't want to see anything else there. So it would be better if we could use comments to get rid of such lines. And it can be done also in an automated way, so you can let something go across your program and comment out these lines. But it still, even like this, it distracts you, and it's not doesn't look very good. So, what would be the other solution? So to make this from the outside would be something like this. So it would be nice if we could say that we want to there are there are two cases. Let me just see whether I'm range monitoring. This is an advanced version that a bit advanced version that I'm showing. Just would be maybe we can skip this access monitoring. We can go already to this advanced version. Well, let's get back to this access monitoring. Sorry for this. So I'll close this one. This is all valid that I said so far, but I wanted to show you first something a bit simpler. So we are just following here. That's why I didn't have this there. Whether the point is being moved or like whether the point is being moved or whether being accessed for reading its coordinates. And for that sake, we would need to add these monitoring messages to the program, but we can do this from the outside. So and this is a bit simpler. So if we just focus on this line, so we could specify this like in plain language. We could say that we want to have additional note or message before the point is moved by the x-axis, and we want this to be like this message. A point is being moved by the x-axis. So we can say this, specify this, and you can in this simple case you can be sure that this is a kind of very deterministic. So the thing is that you could yourself make a small preprocessor program that could add this line to your program. Yeah, you can imagine this. And this has been done, and not exactly in this way, because in the end this language works with already compiled code and adds this into that code. But it doesn't really matter. We don't have to worry about about the exact mechanism. the thing is that when you write this, you will be affecting your code from a separate entity. You will not have to change your code, and this will change the behavior of your code. And this is a small aspect-oriented program. You can do this also for all other occasions that you need to cover. So they're here. And even you can check what's happening after. So what I added to that code before was the after behavior. And the specification that you use is this practically the same. So if we have a look at this construct, you can see that there are some keywords used to indicate that you are addressing a call. You're addressing a call to a particular method whose signature is introduced here in a particular way. So these are all parts of the syntax. It could be described a bit in a different way, but essentially you cannot change this substantially anyway. And then there's this additional behavior that you want to be performed at that point. So you capture one point in your program and then modify its behavior. You don't really modify its behavior for now, like completely, but you add something before that behavior and you can add something after the behavior. So if we run this program like this, so the example is the same. You can see these messages, so it behaves as expected, no surprise. So this is kind of a very trivial thing. So let's quickly get back to the example that I was showing you at the beginning, which uses the same basic code or base code, but a different aspect-oriented code. So here you can see that there are some methods introduced here that help us determine the range in which which the coordinates are being set. So the thing here is that you're no longer just reporting what's being observed, like what's the value, or that the value has been changed, but you want to monitor a particular range of values, and then to inform the user of the program or the programmer that something is probably wrong. Yeah. So if your coordinates are outside of a certain range. So we could put this directly here into these aspect-oriented constructs, which are called advice. We'll talk about this later and about the terminology. It's not that important now, but I'm just mentioning it. So if you would like to do this, you could put this directly into this if construct, no problem. But this is just to show that you can like further kind of make your code more readable and usable by establishing separate methods for what you need, within this construct that you can see is called aspect. So this aspect actually forms kind of another view of your program. That's why it's called this way. And essentially, an aspect, as you can see, is like a class. Apart from these normal elements of a class, which are, I don't have an attribute there, but there can be an attribute as well. Apart from methods and attributes, it contains special constructs that can affect the remaining program. And here, this change in behavior is conditional, so it does not happen always. So you can see that as we have this one spoiled coordinate here, 900, so we can expect that this should be reported. So let's run this example as well. So maybe I have this range monitoring not really activated. Did I run it as ASP.J or Java? Oh, so I did not include the aspect behavior previously. So now it's run as an aspect application. I will direct you towards like where can you get this. This is Eclipse, but if an edit package called AspectJ development tools. So I will direct you how to install this on your computers so that you can use this. So a special compiler is involved here. So you can see that we have this reported. We can go. We can imagine further things like I think some of the examples you mentioned, and in particular that one with the library for you mentioned this optimization issues that might require modifying the behavior. Actually, not letting something run that is normally being run, or changing it for something else. So far we are just like observing things, monitoring things, and we are not really affecting the program behavior. So let's have a look at this example. Range control. So it's not enough for us any longer to just observe that something is wrong. We want to prevent this wrong behavior. So we want to prevent somebody from setting this coordinate, either x or y, to a wrong value. We had this before and after change of behavior, and this one is called around. Maybe sounds awkward. Maybe it could have been instead of around. But the idea is that you can capture any point in your program, like clearly distinguished point in how your program is being run, and can hold it and then like run something before, run something after this. So it's essentially around. Yeah. So here we actually, what we do is not that we run something before or after, but we prevent this program, this point from being executed. So we hold it and hold it indefinitely if the coordinate is wrong. If the coordinate is correct, we let it proceed. So that's why this clause is called proceed. So actually, when you look at this, you can read it in plain English, almost like could have been in French as well. Actually, Visual Basic had this. I don't know whether they still do this, but it was delivered in kind of different, adapted to different languages. Those constructs, so it was really a mess. So because then I think the different versions could not be around. If you set the language to a wrong language, if you said have a different language for your office, then it was a problem. I'm not sure anymore whether this is still like this, but there were some things around this. It's just the choice of the language that you're like it's a lexical thing. The problem. So here we have this example of. Oh, let me run this example. Make sure that to assure you that everything is happening as described. So we can see that so we still report that the coordinate is out of range. These 900 are not set, so it remains 0 because that's the default value. For the attribute, you can see that there's one more thing here to observe. I added this because we need to work with this value as previously. So I did not explain this in the previous example, but we captured not just the point of the execution or in the execution of the program. We also captured a part of the context. And a significant part of the context here is the value of the attribute being changed. Or actually not the value that we plan to the attribute to set to. So to be more precise, this is actually the argument of the method being captured. The call, not the exact call. And this is being done by this construct, and for now, let's just leave it like this. That the syntax is like this, but I will explain why this is being connected by n. So for now, let's leave it like this. But the important thing is that you can capture the exact value of the argument, and then work with it. And you can actually change the value. So we are not changing the value here, but in the next example, we will change it. So the thing is that what we develop might be like scrolling through a kind of a set of values, like for the games, like for those platform games where your hero is kind of entering on one side of the screen, and then when it goes to the other side of the screen, it, or he or she reappears on the opposite side. So actually, if you want such a behavior, so just to keep, so if someone is setting our coordinate, our point to a value of a coordinate that is outside of the scope, then it just has to be changed, or like recomputed to the correct position after we apply the scrolling. And this can be done by recomputing through modulo. So we can do this as shown here. The important thing from the aspect-oriented point of view is that we are recomputing this value and delivering a new, or putting this new value instead of the original one. So it does not have to be a fixed value, it can be a computed value based on that value or some other things that we want to consider or need to consider. So in our example, of course, this should be like this 260 is this 100 is fine, so 900 set, x is set to 900, and it's being computed to 260. So this is no longer monitoring. Why would we want to do something like this? Why would we need this separately from the rest of the program? Why wouldn't it be this a part of the basic logic of our program? You can imagine that your point class could be used in very, very different occasions, and its intent, basic intent, is to represent a point in space. You don't want to spoil this, so its versatile use is based on this. If you add some behavior to it, then it becomes something else and cannot be used in general anymore. For some programs you might need these recomputing of the scrolling of the point. For some occasions you might not need this. And when you have it as a separate entity like this aspect, so it's clear what's happening, and you can just switch it on or switch it off. So if I put this aspect outside of the program like this, where is it? Real fast exclude, like this, I guess. And if we run the same example, it behaves this is just the plain behavior. So it's as easy as this. So no changes to the code. You just put one module in or out, and the behavior is changed. And I have one more example. But maybe actually I'm not sure whether we have to go through this one, but I think we will get to this later. But it's just to make yeah, I'll just show you that this can be made a bit more awkward. So your points might be a part of a shape, and you might like to have this point monitoring. It's to have a look at the next lecture, but something like this. I will not show you in all its complexity, but you might like, your point might be a part of a shape, and you might like to, and some points might be like not a part of any shape, graphical shape. And you might like to change the behavior just for the points which are a part of the shape, and not the ones that are not a part of the shape. So then you should use advanced constructs. We are not going to through this at this point, but it can be a really more complex and adjusted to what you need. So almost any occasion that you can imagine can be covered by this construct that is called a point cut. Point cut. There are like primitive or elementary point cuts in aspect J, out of which you construct your own point cut. And it's an art of constructing the exact point cut that will capture the points that you need to be captured and not the ones that you want to skip. So we don't have to look at this example. Do you want to get back to these examples? Do you have some questions regarding this? So now it's not the point to get into depth with the syntax of aspect J and so, just to get the feeling that what can be done, and you see that it works. Like it's a pretty understandable thing. It's not just that we imagine some things that could be done, we would like, we have some desires that how nice it would be to be able to change our programs like this, but it is actually possible, and it's possible in Java, which is kind of quite very much used in programming, although many of you might not prefer Java, and there's a strong critique for Java, but many jobs are based on this, and you could imagine this quickly applicable to like really industrial examples. If not for the real application that would be delivered to the clients, then at least at some point for some versions, and then when the things are made clear, the code can be kind of put really inside, either automatically or like by some tools, or by hand inserted into certain places and delivered like this. So let's go way higher. Let's go to use cases. Use cases are not programs, and they are not even UML. You might consider UML class diagrams quite close to programming, sequence diagrams and so. But this is just plain text. What do aspects have to do with use cases? So let's have a look at this use case. This is a use case from for an e-shop. Place an order, and it's just a simple use case. Like you see that you are familiar with use cases. I know. Yeah, sure. Yeah, good. So you're familiar with use cases. Either you've had software modeling with me, or principles of software engineering in your bachelor studies. Yeah, so you can read this. But anyway, use cases are meant to be read by lay people, like not non-experts, inexperts. Like you could show this to your client and ask them, is this okay like this? So customer selects to place an order. Then this search product is being activated. We will see this. We can see this use case separately, but I'm not going now to show this to you. This is called include, but you don't have to even to explain this to that person, because it's like just, okay, have a look at this use case. Is it like this that such products should be performed or not? But let's for the time being, we are focusing on this use case, so we can skip following search products for the moment with the client, and just ask him whether this customer confirms the product selection. If the product is available, then the system includes it in the order, and so on. Is this like this? Do you imagine the behavior to be like this or not? So you can discuss this with your client, and no special knowledge is required to read this. Compared to your mail, this is quite more accessible to the clients. You can add some use case diagrams like this. Yes, like this is included. It's a small picture, but doesn't really matter. If we go to our program code, it might be implemented a bit like this. So at one point we will really activate this include like a method call, more or less. There's another way of introducing other behavior to use cases, and it's based on extending what is being here. This is like we strive in use cases for the clarity of the basic scenario. We don't want to distract the client very much from this basic behavior. We already have this one distraction by calling this use case search products. But we do not want to spoil this use case too much. And in a sense, search products is a kind of a natural part, or you expect this to be there, and it's nice to see it mentioned there, so you know that some products are being searched before they are being put in your order. But there may be something else. There may be that you would like to check something, like to check whether the products are available at all before you allow some things in your use case. And if you would be adding this, you would be adding that somewhere here as an additional step, or several steps even. And that would even like just making longer use case longer is bad enough. But this behavior is not an essential thing to understand what does place an order mean. And it's kind of a bit of exceptional behavior, so you'd like to treat it outside. So for this, in use cases, we have extensions. So extension use cases. Basically, we might skip this setting of the extension point and just go right to the step that you want to affect. But it's better to do this because we know then that some use cases depend on these steps, and if we renumber the steps, we clearly see that we need to change this here. Yeah, so we don't have to change all those use cases that depend on this extension point. So your extension point mostly is one step, but it can be also several steps. And you can do whatever you want with that step. You can say, okay, this additional behavior is to skip this step. and do something else. Or this additional behavior is to add something to this step, and this is the occasion here. So, and it's exactly after the checking product availability extension point or to place an order use case, do this. Check the quantity and see whether somebody has to be warned that or notified that more products had to be put on stock. Just recall that one of the constructs that we had in aspect-oriented programming was a piece of advice called after. So you have here after. Could be before, or instead, or around. You could use these. It's like here we don't have to stick to the exact exact words, because what's important is their meaning, and here the interpreter is a human being, so we can find our way out with very different expressions, unlike compilers. So this is very much like aspects, isn't it? And it's not even code. If we would program this in a normal way, like without aspects, we would end up with something like this. So our ordering code would be spoiled or interleaved with this additional behavior. I don't know whether I have some. Yes, I have this sketched aspect-oriented way of implementing would leave out this red thing, so your ordering would be free of checking whether there is enough there are enough products on the stock, and you would have this behavior in an aspect. If you want to get rid in use cases, if you want to get rid of the use case that extends that adds some behavior, like through this extended relationship, what do you do? You don't want this behavior in your specification. What would you do? You have this basic use case that you want reserved, but you don't want this one anymore, this modified stock one. What would you do?
Exclude that extension and execute only that main flow.
You would just drop it.
Yeah.
Nothing else. You don't have to modify it. You just scrap the page out or the book or delete it from your file. Just don't showing it to your customer, to your client. Do you have to modify this? Do you have to get rid of this extension point?
I think yes.
Why?
But we don't have any more this extension point. Then why we should show this extension point in this use case to the customer?
Yeah, it might distract the attention, so it would be better not to have it. But essentially, it does no other harm, so it does not affect the behavior. If you leave this extension point, it does nothing. It's just this is just a label. Nothing more. So you can leave it. So it's just with aspects. You just drop this one and you're ready to go. So let's see one other thing with use cases called peer use cases. Peer use cases like your peers, yeah, like you know what a peer is. So peer use cases are not like sometimes people call these included use cases subordinate use cases, and they really seem to be, these search products seems to be like a lower level use case, particularly if it's not being activated on any occasion directly, but just in the context of some other use cases. This is a kind of an include-only use case, and it seems that it is not that important as those use cases like place an order, cancel an order, which incorporate this behavior. And these use cases that represent the most important user goals are typically are not interconnected. They just, when you draw a diagram, it's just basically they are just bubbles there. So no relationships between them, but they are related. When you implement them, they share some things. And this is often indicated by putting these use cases together in one diagram. I did not put a frame around this to show that this is one what's called subject in use case modeling. In this UML part of use case modeling. So the main part of use case modeling is completely unrelated to UML. That's the text that I showed you. The diagrams are just an overview, but this is an interesting thing that you can put this frame around some use cases and label it. It seems just kind of a simple thing, and what does it matter? But in reality, this might represent kind of a package in your program or something like that, or a part of a package. Maybe it will not be an exact programming entity, but it will be kind of, you will feel it in your program, and you feel that these use cases are somehow related just by, you know, like they share some notions. Here we have this order, and if we represent these use cases like what's behind them in our program, and we do not want to go to a complex class diagram. If we just want to represent or relate them to the classes that they will be based on, we can use these elements called collaborations. So maybe you've seen this before, maybe not. So it's just a collaboration is just an abstract representation of any behavior. Like you can imagine that there will be a place and order sequence diagram, but you don't want to bother drawing it. It's too complex for you, or you don't want to do this. But you want to say that there is this sequence diagram, and here it is, represented by this. And in this sequence diagram, these classes that are hanging on this collaboration will be interacting. And this sequence diagram or this collaboration is actually a realization of this use case. So that's why this realization relationship is used. So this is a kind of formal, if you want to attach classes to your use case, you could associate them like to your use case and say, okay, it's fine. But this is a kind of a little bit more precise way of doing this. Also, you can say that pattern is also a collaboration of classes as it's being implemented. So you can use collaborations to represent patterns. So, but anyway, let's get back to this example and see that not only product, which is kind of expected, and order could be hanging there as well. I've never adapted this example to include it. Order could be hanging there as well, but in our order, the order is about products, and also we need some class that will actively process orders. So let's call it order manager. And for us, in this use case, place an order in the order manager, it's important to have this behavior order product, because it's ordering. In canceling an order, it's important, we also do consider this order manager, but it's important for us to have canceling an order. So these two guys are the same in our program, but for this purpose of identifying what's behind one or the other use case, we would like to see them separately. We could even name them differently, but we could use the same name. So it might be like in our analysis we would come to two different names, and only like putting these two diagrams like this, we could say, oh, these two things should be then, in order to make the program work, put together. Aspect J does not really support this. You can emulate this a bit, but there were attempts, and there are languages that come close to this composition of classes, like partial classes. It's not exactly the same, and there should be some further there should be some further aspect-oriented constructs in order to have this full-blown. But in C# you have partial classes, and you can put them together. Like you can have a part of a class in one file and a part of a class in the other file. It looks like, okay, well, why would I do this? What's the use of this? I want to see everything together, why not? Why putting this into separate files? But by this you might indicate that this is related to one thing, and this is related to other thing, and this might be related to how your code is being developed. By do you do all the things in the project, or there are other people? So one programmer could be maintaining one file, the other one the other file. It's much easier. Okay, you can put these all together through following, through like version control systems and so on, but it might be cumbersome and really annoying. So it's typically the responsibility for particular classes is being kind of determined, and you get some classes, some modules of the program that you're responsible for, and the thing is that some parts of that order manager that you might be in control, in charge of, might be it might be a complex class, and some other people could be like involved in this. So you need to communicate more and synchronize your work. So if you could deliver, or you could work separately on different aspects of the classes like this, and this is not like putting what is this before or after this method, but putting together all the pieces. So like different aspects of the same class. And these pieces, as you can see, are we could imagine easily like this is the case that we have only one or two classes and two use cases, but there could be many use cases, many different classes, and these views of these classes, of different classes, pieces of different classes related to one use case represent one view, one aspect of the system, and you compose these equally important aspects into a whole. So this is a bit a different composition than the one that I showed you before, and it's called symmetric aspect-oriented modularization. We will also get back to this notion later, but the essence is that the whole is being composed out of equally important aspects. So in this point example that we had, the point, probably we would say the point and the basic behavior in that main method were constituting the most important part of the program. And that change of this behavior that was in an aspect was kind of an additional thing. And it was programmed in a way, so in a different construct. It was not like the same construct that you had in the basic program. The classes were there and the aspect was there. So these were not equal, and it was like asymmetrical. So this one affected that one. Here, the composition is symmetrical symmetric because you're composing equally important things into a consistent whole. As compared to this weaving together, it's called weaving together different aspects that affect a whole, which is actually the basic whole. So here this whole is composed like it has this basic part. Maybe the diagram is not completely correct. Yeah, whole with aspects here. So you have this basic whole, basic program, and when aspects are woven, you get this whole with aspects. So basically, that's it. You can see that we have these. This is just a summary, but you can see that we can observe aspects as early as in use cases, and we can make use of them directly, like practically, very much in a very concrete sense in our programs. And this, although you might have not used aspect J or these exact things, this might, and there are things in between. We will check like how this affects class modeling and such things. But since this occurs already at the specification level, we might expect that we could use it or employ it in our graphical models. But my final question to you is whether you, at this moment even, whether these things remind you of something you've observed in some other languages that are not labeled as aspect-oriented. Yes?
For example, wrappers. So like when we're wrapping a function, usually it means we execute something before it and after it.
exactly. So it's in Python.
Yeah, for example.
Annotations in Java.
Annotations in Java. Yeah, they can be used actually. Normally, you use annotations not to modify the behavior, but they can be used also in this way to some extent. And actually, there is a Spring framework is using annotations to express aspects without really like having to modify Java. So you just have this framework, and you can well, you don't have everything as in AspectJ, but a significant part of the capabilities are there. Anything else?
Maybe also in Angular, when a component loads, then we execute some code. Maybe there is an ng on init or ng on destroy, and some examples like that.
Yes. I mentioned here. I have here mentioned some examples. Maybe if somebody came across Scala or Ruby. We mentioned dropping about not prototypes. JavaScript might be also considered as aspect decorators. Actually, that's this mechanism is called decorators. So these languages are not being labeled as aspect decorators. You probably never, like in manuals or like in popular literature, never came across this. So there was a time when aspect-oriented programming was popular, very much like as a research concept, and the AspectJ language that I was showing to you was developed as a research prototype, but with a strong involvement of the community, and it survived. And even now, it's kind of being more or less regularly updated, so it's alive. So there are many dead languages, dead natural languages, and dead programming languages, because there are no programmers that speak those or write programs in those languages, and the compilers are outdated. Like so, for modern applications, you cannot imagine using them. So with AspectJ, still it's kind of maintained and being alive, but the main hype around aspect orientation went away, and there were some doubts about aspect orientation and how it affects everything, and that it's dangerous concept slightly, because you are changing the behavior of a program from one entity towards the other entity, and you lose control and all those things. So for those communities around these languages, it was not probably attractive to mention that to relate to aspect orientation. It seems that there would be ashamed of mentioning aspect orientation, but there are research papers that relate these concepts. So you see, these are quite like when we take just also Scala maybe, but Ruby, JavaScript, Python certainly very popular languages, and these concepts, when you have them on your mind from use cases, they can help you structure your program in a more effective way, more manageable way, because they do not. They have these constructs there, but they do, and they say, okay, you can change this behavior, like, or you can affect your method like this and so on, but they do not provide you this higher perspective of why this is important and where it can be used, all the way from use cases. So that's it for this introductory lecture. these are some conclusions that we can take from or to remind you just what we went through this lecture. I don't think we need to like read them together, repeat them. So the main conclusion is that a call to you is to think about how aspects fit into what you know so far, and to start thinking about what you might be kind of being inspired by this. I hope what would you like to try related to aspect orientation in your projects. So it might be really not related, not even to use cases. It might be related to use cases. You don't have to stick to aspect J as a programming language. So you can revert to your favorite language, or you can experiment with some other language or whatever. You can combine things in different languages if you find it suitable. We will be talking about other things related to aspect orientation at the next lecture. Maybe the important thing is also one of the things that might be interesting for projects are design patterns. So this is what will be mentioned in not the next time, but the time after that. But anyway, I hope that this gives you kind of a roughly a picture of what aspect orientation is. Any questions? Comments? No. So if not, let's have a break and let's get back at noon here. I guess that part of today's class will be a bit shorter, so we will not use a lot of time that's at our disposal. But anyway, we would like to tell you a few things and to organize the work.
We'll
labs. Yeah.
even have an introductory presentation. So.
You have a presentation? Okay, great. That's why I got them on the course, so it would be kind of a bunch of new things even for me.